Hello everyone, I'm rx97 and I will be talking to you about Beet. Woo! So, Beet is a very special tool to us at Smith because it helps us manage all of Smith's projects. It is our main tool for organizing our data pack and resource pack code, including all of Summit. So, throughout this presentation, I'm maybe or maybe not going to convince you to try out a tool like Beet, but I'm just going to add some motivations on what Beat can do from base principles and how it can evolve to support your needs when you're looking at a precompiler. Before I jump into the next slide, I just wanted to break up the precompiler term. Yesterday at the fireside chats, we had a bit of a precompiler chat where some people are interested in using a tool to help them automate some MC function, whether it's a custom syntax that will convert into MC function, so you have a little bit of control. One of the biggest things that came out is writing a lot of your data pack into less files. Instead of creating a new file for every function, you can define it all in the same file. The idea of a precompiler is to make it so you're not writing a data pack directly, but you're writing into a different format that converts into a data pack or a resource pack, depending on what tool. There's a lot of them that exist out in the wild. I'm here to talk to you about Beet as my favorite tool for this job. So you probably don't need Beet. This is a little weird to start the presentation of me convincing you, but unfortunately, the way that we want to use Beet and other compilers, there's a bit of hurdles to kind of go over. Oh, what is wrong with Beet? Beet has very little documentation. This is definitely unfortunate, and if you're wanting to learn a new tool, it can be tough without documentation. Beet is sort of complex. It has a lot of moving parts, a lot of different sub projects within it. You start talking to people, and they start throwing words like mecha and bolt. Um, and you're like, "What are all these terms? Why are there so many vegetables in my precompiler?" I guess it's just Beet, but we have the difficulty of installing and managing Beet. That's thanks to our friend Python that makes that a real pain. Beet has no docs. Beet has a really strong cult following, and as what you've heard about cult followings, they're probably liking the tool way too much. There are a lot of ways to do things in Beet, and when there's so many different ways to do one thing, it can be really difficult to figure out how to do that one thing properly. And finally, did I mention Beet doesn't have any good docs? Yeah, it's unfortunate, but Beet has a lot of thorns in its side that can really hurt a lot of people that are interested in precompilers, especially if they want to learn a tool like Beet. And hopefully we can sort of smooth these over. But this presentation acknowledges some of these setbacks and wants to move past them so that we can explore what Beet is. And hopefully in the future we can work on some of these problems with the community to sort of solve this issue. However, why do all these groups use Beet in the first place? If there's so many problems with Beet, why do we use it for Summit? Why does Game Mode 4 use it to build their data packs? And why is Vanilla Tweaks rebuilding all their data packs with Beet? We can ignore the slide. Maybe I told them to. We're going to learn more about Beet in the next couple slides. We're going to start with the fundamentals of Beet, how to start a new Beet project, and why it's structured the way it is. And then we're going to transition into the Beet umbrella. What are the other projects and why they exist under the Beet project? And lastly, we're going to step into the world of Bolt, which is probably the crazy scientist part of Beet, combining Python and MC function one-to-one. Beet is a development toolkit for data packs and resource packs. What does that mean? Well, Beet understands your data pack and resource packs. It doesn't introduce a new format. It loads in the vanilla format for how it's laid out. The same data folder, functions folder, and the pack MC meta. The difference is the Beet will just load in that file and then operate them. So the structure of Beet is understanding your setup for data packs and resource packs. It operates on that structure, allowing you to automate the changes that you want to make. And lastly, it sets up in the main orchestrator for organizing those changes via a pipeline. So essentially, we have our data pack structure, we have a change we want to make, and we want to do those changes in a defined order so it's deterministic. That's the main principles with what Beet wants to do. The Beet program is often used in the terminal. Now, this image might be a little bit blurry and small, but essentially, we generally use the Beet CLI that you can install via pip install Beet. And that provides a bunch of tools. Mostly what people want is just building the final data pack. The main component of a Beet project is the Beet config file. In normal Minecraft projects, you have a pack MC meta file, and that just lets you define a couple things like the pack format and the description and maybe overlays and filtering. In a Beet project, you don't really need a pack MC meta file. It'll work, but you can omit it if you don't want it. Instead, you can put all the information in a beat.json file. This helps you define all the metadata that you're defining before, including some extra stuff like the author, the name, the description. You define a data pack field or a resource pack field for how you want to load those files, and an output directory and where those files want to go. But what's really great about the beat.json file is that you can do whatever you want with it. There's also a YAML format or a TML format. And maybe we should add more. It seems like people like JSON 5. The Beet config is an extremely flexible paradigm. It allows you to define your config as little as you want or as much as you want in whatever format you want. All it tells Beet to do is, what is my project? What do you want me to change about your project? And where do you want me to place your project? In some words. We're going to be using JSON for the rest of this project, for the rest of the presentation, because a lot of people are familiar with JSON. But I personally use YAML because I find it a little bit easier to read. The Beet config allows you to find a lot of other fields, like the pack format you can do directly in the data pack field. Zipped will allow that data pack to automatically zip out. And you can even extend other configs. So if you want to have a config for local development and a config for production development, where you want to output a zip, you can do that. Beet allows you to tie your configs together, giving you the control rather than taking it away from you. The core of a Beet project is the pipeline, which is an ordered list of plugins. This is the Python aspect of Beet, where you define a Python function, essentially, that makes changes on your project. And the Beet config just says, I'm going to run this function, then this function, then this function in a list. So in this example, we have require, which are Beet plugins that run before loading the data pack. And then we have pipeline, which are Beet plugins that run after loading the data pack. So the way it's ordered in JSON is just for legibility's sake, but essentially we load this plugin called Beet contrib auto YAML. We load the data pack from the source folder, and then in the pipeline we run my plugin beet.contrib.strip final new lines and beet.contrib.minify.json, and then lastly the output folder. Well, how does this pipeline work? We know it's Python code, but how does Beet actually go through this pipeline? Let's just go through that example in more detail, step by step, and see what's going on here. The first thing is how the Python functions, Python plugins for the Beet plugins work. This is a Python file that takes one argument, context. If you're familiar with Python, I've used type extensions here to make it a little bit easier to tell what's going on. But as always with Python, you don't have to use types if you don't want to. The main process here is this context object. This is the entire context of your Beet project. It contains all of the loaded data packs, all of the loaded resource packs, all of the meta information like the author, the name, any meta information that you personally define, and a lot of helpers. So in this example, we've used one of these helpers, context.generate, to generate a function file at foo:\bar. So rather than us writing foo bar in our data pack when we load it, we're doing it on the fly with code, which means we could do whatever we want. We could make a web request and put that in a function file, or we could read a PDF file and put that in a function file. The world is your oyster with these Python functions. The Beet pipeline gives you a lot of control when ordering these plugins. This is a bit more of a complicated example here, but it just shows how flexible the pipeline is. Plugins can be dependent on other plugins. You can add a cleanup phase that happens after the yield statement, and you can even generate an entire sub project in your actual pipeline, and you can have infinite nesting if you want. It really can be as simple or as complex as you desire. But the idea is the flexibility is in your hands. One of the reasons why Beat sometimes is a little bit daunting to new users is because of how flexible it is, because there's no one single defined process to do something. It can be really tricky because everybody has chosen their own way to do stuff, so that can make it a little distracting for a new user. Here, we just show a bit of a setup for how plugins might work in this sort of complicated setup. We essentially go through them in order, and then it comes backwards when we have the yield statements. But if you don't want to use this sort of setup, you can just have them as a simple list. That's what a lot of people do. Now, the earlier config that I referenced earlier, we can break that down together. The first plugin in this list is Beet contrib.autoyaml. One thing you might notice with the Beet library is that it is a batteries included experience. This also means the Beet project comes with probably hundreds, maybe tens of included plugins. And there's a lot of them, and they do a lot of different things. Part of using Beet is figuring out what these default plugins do and how you can use them to your best advantage. So in this example, I'm referencing beet.contrib.autoyaml. And if you're familiar with Python packaging, the Beet would be the Python package, contrib would be a folder in that, and then autoyaml would be a Python file in the contrib folder. And we just reference that directly in the Beet config. This plugin allows you to write JSON files as YAML files. So rather than doing data/Minecraft/loot table/entity/zombie.json, you can do zombie.yaml. And here's an example of that. This is a zombie.yaml file that exists in source blah 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 all the way to entities/zombie.yaml. Beet loads this normally when it gets to the loading step and will actually convert that YAML into a JSON file for the final compilation. This is extremely powerful. Rather than being limited to what files you want to load, you can tell Beet what to load and then decide what to do after in a pipeline step. The next plugin is Datapack. Now, Datapack isn't in the pipeline section, but I've listed it as a plugin because that's how it works internally. All this does is loads your Datapack. You can include any meta information for how that Datapack wants to get loaded. This includes, whether you want to zip it, whether you want to give a description, a pack format, and you can also load multiple data packs. If you have a library data pack that you would like to just merge with your current one, well, just add it to the list. And Beet will handle the merging process for you, doing the exact same merging that vanilla does, so making sure that your tags will combine properly, and your sounds file would combine. There's a couple of different rules there. Everything in Datapack will run after require. So it's sort of ordered in that way. If you need something that changes loading, you have to make sure you require it. The next plugin is a special plugin, My Plugin. This was the plugin that we listed earlier that generated Say Hello World at foobar. After we run Datapack, the Datapack config line, we now have the Datapack loaded, but now we can generate a new file. So you can see here, this would have generated something in the foo/function bar.mc function file. And here's an example of that plugin again. The next plugin is strip final new lines. This is sort of a very simple plugin that just goes through and removes the final new line at the end of every file. It's sort of like a helpful cleanup function if you want a tinier pack size at the very end. And that kind of leads into the next one, the minify JSON. This is another plugin that takes every JSON file and minifies it. So it gets rid of all the new lines, the tabs, everything that you don't really need. Very mindful looking JSON file. So this allows you to write the data pack as you want, but then you can, output an optimized data pack if you really want. You just choose what plugins you want to use, and Beet will just run them in that order. That's the superpower you get with the Beet pipeline. This is an example of what the output looks like. The build folder on the output line is where that data pack goes to. And you can see it's called dummy data pack because that's the folder I wrote it in. It outputs a packmc meta file for you that puts in that same information you defined earlier. And you can see here there's the foo function bar MC function, which is our say hello world, and Minecraft/foo table/entities, which does zombies.json. The idea here is we generate a bunch of files that come together with the files that we've already written, and that gives us the ability to automate it. So we can generate new files from other files. We can use other libraries to do whatever we want in our data pack, and also resource pack. I've shown data packs here, but resource packs would work as well. There's a couple fundamentals with how Beet works that I think are pretty important to understand. The first one, Beet always outputs its own folder. One of the problems with people using a lot of tools, especially on websites, is when we run a script, we usually just dump those files directly in our data pack. Whether we go to Misode and just generate a file and dump it straight in there, or we have a Python script that generates an in-game compendium, it basically just replaces itself in the source of your code. Beet will always output to its own folder. Your source files and your build files are two separate directories, and they don't get intermixed unless you do something really bad or something. Second, Beet will not open your files unless it tells you to. If you send a data pack to Beet, nothing will happen to it. It basically just passes it through as long as it matches the correct namespaces. That's interesting because if you have a really large data pack or resource pack and you don't want to open every file, Beet won't touch them. It will only look at the files that you want to and read those on the fly. So for minify.json, if you only ran minify.json, it wouldn't open any of your MC function files. It only opens the JSON files, minifies it, saves it, and continues. Beet respects your wishes. It will not go beyond what you want it to do. Number 3, Beet always loads any valid data pack and resource pack, mindful of updates. This means if you have an existing project outside of Beet that's a data pack or resource pack, and you want to try using with Beet, you don't have to worry about conforming your pack to Beet standards. You can even just throw it in a folder, in like a source folder, write a beet.yaml file that loads it, and then you can maybe write another data pack that gets merged with at the very end. Beet respects vanilla, and it's always a core principle to make sure that it doesn't break vanilla. It should always work within how vanilla works and make sure that it loads everything properly. This should be really helpful for anyone onboarding. If you want to try a Beet plugin for like one specific thing, but you want to work on your data pack as normal, this lets you opt in into certain features. Now, within the Beet umbrella, there is a lot of other projects going on. Even within Beet, I only scratched the surface of maybe 5 to 10% of what's possible. But there's also the entire Beet ecosystem. If you tapped into the Beet booth that's actually right behind you, there's a couple of sub-projects, and I've gone into more detail there, but here they are on the screen. Beet is the core of the entire ecosystem. You don't necessarily have to use Beet with everything, but generally most Beet enthusiasts are using the Beet toolchain in their terminal. This just lets them run their project on the fly as they wish, and it makes it very easy to have one tool that runs everything. You don't have to have like a bunch of random scripts that do stuff. I haven't really touched on Lectern at all, but it's one of those earlier projects that has its uses. It allows you to write all your data pack into a single markdown file. This is pretty interesting from a point of view of literate programming, and it's fascinating, but it's not something we'll talk about in this presentation. Mecha. Oh no, my emoji is gone. Oh well. Mecha is one of the more complex projects within the Beet ecosystem, and it's what powers what we'll be talking about in the second half of this presentation, Bolt. I like to think of Mecha as Brigadier for Python, but that might be a little bit out of scope. One way of thinking of Mecha is it understands Minecraft commands, and it's able to validate and operate on them from a Minecraft commands level. So in the point of view where Beet understands the data and resource pack from a higher level, function objects, root table objects, etc. MC function understands the commands within the MC function, understands the say command, the tolerate command, the execute command. It uses something called an AST, which is a concept in computer science that talks about syntax. And it's a little bit magical, but it allows you to operate on those commands from a code point of view. This means if you want to add your own command that then, when compiled, converts into a vanilla command, you can. If you want to add like a /debug command or a /hello world, Mecha gives you the tools to edit its understanding of commands so that it can understand when it reads your file. Then it gives you the tools to operate on that understanding, generating new commands, like a vanilla one, and then compiles it in the same way that Beet does and makes it and puts it into a normal function file. There's a little bit of a hefty explanation, but the crux of that landed us with Bolt. Bolt is probably the star child from the MCB ecosystem. It's only one part of it, but it essentially allows you to write Python in line with your MC function. Beet had you writing Python on the outside, writing it as plugins that you can sort of compose together. Bolt registers Python as an MC function command. So rather than just writing Python and MC function separately, you write them together. So let's look at some Bolt examples. Bolt. Here's an example of what Bolt looks like. Now, if you aren't too familiar with Python, this might look somewhat recognizable and somewhat not recognizable, but the idea here is one line is Python and the next line is MC function. And Bolt and Mecha work together to make sure that it understands the difference. Essentially, what this would be doing is writing summon chicken in an iteration. So you do like this. I'm writing in chat because I forgot to put it on the slide. The main idea here is... Oh, are we not seeing the slide? I'll let a moderator get on that. Yeah, the main idea here is the for loop acts as a pre-compiler step. Mecha sees that command that Bolt registered, and it says, oh, it's a for loop. I want to do the next line multiple times in a row. The output of this is summon chicken at slightly different coordinates 16 times in a row. So with 2 lines, I wrote 16 different lines, and I wrote it in a way that works from a Python point of view and an MC function point of view. Bolt does a really good job of merging these ideas together, giving you a really fluent syntax. Let's take a look at some other Bolt examples. All right, this is another facet. These are multi-line commands. So before Minecraft added their version of multi-line commands, Mecha and Bolt had this basically when it started. We have an execute clause, and then we have every single subcommand of execute with a comment on the same line. This is really interesting because we have so many more tools when it comes to commenting our code. Like we can write a comment in line, we can organize our code however we want, and we don't have to think about those backslashes. Bolt will just collapse this into a single command at the very end of the day. And another example of this is if entity at s distance 0.6 and so forth. This is an implicit execute. We don't need to use execute. We have our own language here. Mecha will be like, hey, there should probably be an execute here, and it'll just put that there. It registered if as its own command, and then when it gets compiled, it adds in execute if as the final command that Minecraft understands. With Bolt and Mecha, it gives you the control of how you want to write commands rather than Minecraft defining how it wants its commands. The last example in this line is an implicit execute. If entity at a function ./abc:. This is a pretty hefty command here. What's happening here is we have our normal command, and it's going to call this function. But instead of making a new file for this function, what if we just write it underneath? Mecha allows you to generate multiple files in the same file. Rather than having the file system control how you write your code and you use the file system to support that. Writing your commands inline is a concept I've seen at some of the other Beet compilers, but it's really popular for one reason. You have the control over your file system and you have the control on how your source is laid out, rather than the game controlling that for you. And this makes it very convenient because you don't even have to fudge around with relative paths and stuff like that, or with absolute paths. You can just do it relative, and the game will understand what you want to do based on where it's currently located. Similar to relative paths in like a bash terminal, if you've ever used one of those. So we've seen examples on how powerful Bolt is, and I guess I have another example here. Yeah, this one's really cheeky. If you've looked in the advancements menu of the main server, you'll see that there's an rx97 advancement. Well, if you're curious on how that's generated, well, I just used Bolt. I had a list of all the locations of where they are. I iterated through all those locations, added to the criteria, and then just made an advancement in my MC function file. This is extremely convenient because not only can I generate MC function, but I can generate anything. Anything that's JSON. I could generate a shader file if I wanted to. It's all controllable within one syntax. Very convenient. All right, I forgot about this meme. All right, using Bolt. The base of a Bolt project is also a Beet config, but the config now has a little bit more stuff. In require, you put in Bolt, and that just tells Beet, hey, I'm going to be using Bolt in this project. Before you load your files, make sure you know what Bolt is. We must require Bolt to make sure that Beet understands where they are and what new commands exist in the world, because we're adding new ones. We load our source repo, and then we have our pipeline, which has Mecha. Mecha is what actually runs those commands. It'll actually check if your commands are valid or not, and if it sees a custom command, it'll convert it to a Minecraft command. This is essentially the engine that runs the entirety of Bolt. The very last thing that you haven't seen is this entry point. This is very specific to Bolt, but it just tells Bolt where to start looking. A lot of people put star here, but you can also put namespace :main. That just essentially says, hey, Bolt, this is your main file. This is where you need to start. A lot of programming languages has like a main function. This is just Bolt's version of that. This is an example of what Bolt code looks like. This is our very simple main.bolt file. Function foo : bar, say hello world. And in the file system, we have this is the output, sorry. This is the dummy data pack, and it outputs our file at foo/function bar.mc function. But in the source folder, you can see where this file actually exists in the source. Data/namespace/module main.bolt. So both files actually go in its own folder called module. And there's a bit of an exception for this, but I won't dive too much into the details here. But the idea here is we put a file in our source folder, and it doesn't even output in our build file. It generates a completely new file. Bolt files don't necessarily have to go into the output file. They get read, consumed, and they generate the files, and then they get ditched. There's no need to output them. They're just source code. Everything in Bolt can be defined in a simple file. You can define your module files, your texture files, your shader files, your advancement files, loot table files. All of that can be defined in a single file if you're crazy enough, but it's up to you. I am crazy enough, so. Let's take a case study. I think it's a bit interesting to look at these simple examples, but I have the unique opportunity to explain how do I generate these slides that you've been looking at all throughout this week. Well, let's take a look. Now, I will warn you, I wrote this pretty hastily. So it's not the best, but I think it actually showcases a couple of techniques that are really exciting in the Bolt ecosystem. First of all, these are PDFs. These are slide decks. How are they shown in game? Well, a PDF file doesn't just appear in game. We have to convert it to a PNG file. From the resource pack side of view, every single slide in the PDF is converted to its own PNG file. And this is the code that does it. If you want to zoom in a little bit, you can kind of see what it looks like. But the main thing is we're using an external library here, PDF to image. This is somebody else's code that I have no idea how it works, but I used the one part that was useful for me. I needed to take one slide and convert it to one PDF at a certain resolution. And I needed to generate all the Minecraft files to do that. What's fascinating here is this was actually written like a Beet plugin. There was no reason for this to be a bolt file, but I've used it as a bolt file because it was convenient for me, and that just shows how flexible bolt is. It's not just a new syntax with Python MC function. It is literally Python inside of MC function. It just works. In this situation, I'm using this PDF to image dot convert from path to take my list of slides in a folder and convert them into a set of PNGs. Then I'm creating a resource location for where those need to go, while normalizing where like the pathing and stuff like that. And I'm generating a texture file and a model file. So you can see context.generate resource underscore location texture, and the same one context.generate resource location model model. Now there is some behind the scenes stuff that's happening here. I haven't shown every function here, but the main idea here is I'm just able to generate these files based on a Python function, and that makes it extremely flexible. I can just iterate through a Python list and generate normal files, and that is how all these PNGs are created. I'm even setting the opacity here with some pillow code. Function paths in Bolt are very convenient. Now, there are a couple ways of doing this, which is one of the thorns I talked about earlier. So in the panels data pack, I use the tilde symbol. This is a relative that works with Bolt, and it makes it convenient because I don't need to rewrite panels speakers every time. So it's just an example of how concise you can be with Bolt and how it's really easy to leverage in a single file. Yeah, also I will say with syntax highlighting, there is actually a syntax MC function that works really well with Bolt. It was actually originally the Bolt one. I didn't use it for these images because I kind of forgot. Now, here's another cool thing about Bolt. Bolt is Python. Python is Bolt. That is a really funny sentence. I actually find myself writing a Bolt file, and then I've written most of it. I'm like, there's actually no MC function here. And then I just change the ending from Bolt to Python and use it as a Python file. And Bolt treats them very similarly. And that just lets me use like the Python language server and stuff. In this example, I'm using a library that the community came together called Bolt Expressions. And this is not something I'll completely dive into, but it's a piece of infrastructure that I use for the panels. So in this example, I am calling from this Bolt Expressions library. I'm defining sub functions here, and I'm just doing normal Python if statements with these objects. What's going on here? The Bolt Expressions library defines special methods that Python understands. But what happens is rather than doing like a normal Python, A is greater than B, it actually just generates the corresponding scoreboard code. This makes it very convenient when you're lazy like me, because you can just use Python to write the MC function you want to. But what's really nice is it's opt-in. You don't have to use this functionality. You could even write your own library for this functionality. The power's in your hands. What's really crazy about this is Bolt Expressions is not written as a Beet plugin or with Beet in mind. It's written as a completely normal Python package that exists for the Python ecosystem. Now, I'll tell you it's not going to necessarily work if you just import it in a normal Python script and you're like, oh no, what's going on here? It uses the Beet library for a couple things, but all the logic is written in Python, and that just shows how flexible this ecosystem allows you to be. If you want to write a piece of, reusable code, you can just write it in Python, push it to PyPy, and share it with the community. And that is what the community has come up with. This is just one of several libraries that the community has put together to make writing MC function a bit more fun. A lot of it is just sort of seeing how far we can take this, but I use a lot of this all the time when I write my own Bolt, but that doesn't mean that the Game Mode 4 crew is using this all the time, or then Vanilla Tweaks is using this all the time. We all sort of have our own ecosystem, that we enjoy using, and it's honestly my favorite part of the ecosystem is the control you get. Here is another example of our main.bolt file. I didn't add any information here because it's a little bit of internal details, but it just gives you a little bit of idea of the syntax. Again, this isn't the prettiest syntax. I'm using some anonymous functions that I usually wouldn't use, which just generate the function name on the fly rather than me deciding it. That doesn't make it that useful to read from the outside point of view, but you can do it if you want to. In this situation, I'm iterating through my PDFs and I'm loading up a list I can use later. And in the next step, you can see here, I actually iterate through all of my panels and add a start function for each one. Um, yeah, this is just an example of some syntax here. And here is how the panels look from the output point of view. When I build my data pack, build my Beet project, it produces a data pack and it produces a resource pack. On the data pack side, you can see here, all the functions that I've written out just exist at the root. It takes my namespace panels, and it adds a panels.load, panels colon load, panels colon reset, panels colon start. Um, there's some subfolders like slide, and that's what handles, the next slide, the previous slide, skipping slide. All of that is basically generated based off that tilde syntax when I was talking earlier, the relative functions. On the resource pack side, I've generated folders for the textures in the item folder, and in the models item folder. And I generated all of the custom model data that to do in the past. So you can see there's 0.png, 1.png, 2.png, 3.png, so forth. You can imagine that this would have been a pretty big pain if I had to manually convert my PDF into a folder of files and put it into the resource pack. Maybe it would have been faster for the first panel and the second panel, but after 16 panels, I would have gotten pretty tired. I don't think this would have been that possible without a tool like Beet. It just makes it so much easier for me to generate these files on the fly. We're getting towards the end of our panel, but I know there's a lot for me to dive into here. There's a lot of resources when it comes to Beet, and unfortunately, we don't have the docs to support the ecosystem. That's something that the Beet community is really coming together to work on, and it's definitely at the top of our list. But in the meantime, we have put together a couple links that some community members have put together. The first one is the examples folder in the repo. One unique way with how Beet is organized is it's very well tested and very well structured from a Python project point of view. Every single feature that's added to Beet has a test case. Those same test cases also act as examples. This has a consequence. Oh, I threw my mic. Oops. This has a consequence of your examples looking a little bit like tests, which can be a little bit difficult to parse through. But what's really helpful is if you don't know how to use a specific feature in Beet, there is probably an example that showcases how to use it. And they are all their own sub-project that you can use and you can reuse. You can just yoink and twist it, copy paste in your project, change a couple lines, bam, it's yours. Really love the examples, and they exist for all the umbrella projects. They exist for Beet, for Bolt, for Mecha, for Lectern. Great resource. Next one is the channel in the Beet Discord. We like to call it Beetcord. But the Beet Discord has a lot of lingering resources. I've listed the tutorials channel, which has a bit of an overview of all the different options in like the config folder. It has its own getting started guide for both Beet and Bolt. And just contains a couple of helpful links for where to find stuff. So it's where a lot of people get started with the Beet project. The other great source of information is the news channel in the Beetcord. That sort of is a history of all the different updates to the Beet project. Beet is a project that's like 4 years old, and in that time, it has essentially evolved on top of itself several times through. Back in the day, we used to use Jinja for generating our data packs instead of, uh, Bolt with Python and stuff. So it was quite a different world back then. What's really awesome is that entire history of every single decision made. That's all contextualized in the news channel, and the project's creator Fizzy spent a lot of time making sure every single change and breaking change was thoroughly explained from a motivation point of view, so that you can always go back in history and figure out how a certain thing works and why it was changed. really helpful for some of the niche features of Beet, and I find myself looking up that channel all the time. The very last resource is this Bolt syntax guide put together by VDV Man, one of the other maintainers for the Beet project. And I will be linking all of these links in our Beet post alongside. I'm sure Nexus will paste them somewhere. This is a Google Doc that sort of showcases some of the Bolt syntax as a file, as a README. It would be a great resource to use for our final docs, but it sort of serves as a getting started guide for Bolt specifically on how the different features of Bolt can interact with your project. Credits. I want to shout out Fizzy, who was the creator of this project. Fizzy is a sort of inspiration when it comes to Python data packing. They started the original NBT lib library that made working with NBT files a breeze in Python. And they're the original, they're the founder of the Beet project and fundamentally have been in charge of all of the updates. Fizzy, unfortunately, is very busy with IRL stuff, so it's been more of a community-run project as well. But every time he pops in, he usually does a huge feature drop. It's been pretty exciting. I'd also like to thank all the other contributors. There's honestly a lot of contributors, but VDV Man and Misode have been some of the main maintainers as of late, alongside like AirDocs and the Wii. The community for Beet is really strong, and it honestly is what kept the project really going strong. It's not just one person anymore. It's a group of people that all use the project in their own ways, and that's what's really awesome about this community, the Beet community. I also like to shout out all the people that helped me with my slides because I procrastinated / I was running a Minecraft convention. I don't know if you've heard of it. But yeah, this is essentially where I can leave off. I'd like to thank everybody for listening to a little project called Beet, and how exciting it can be for running a Minecraft convention. So, shout out Huglet, who also helped. Huglet is featured in the Beet booth, but yeah, I guess we can take some questions.
Yep. Just throw your questions in any of the chats, and we will try to answer them best we can.
What's the difference between require and pipeline and beat.json? That's a great question. Let's see if I can guess the slide. Nope. 10.
It's definitely not the first one.
25. Okay, that's a good slide. Okay. This is sort of an artifact of Beet that I think the community wants to change a little bit. It currently has a require is a list of plugins that run before the project loads any information. So any setup stuff or anything that you need to register, like a new command or like a new resource location, like if you want to load Optifine files, for example, you put that in required because you don't want to load your data pack, your resource pack, until Beet knows what to load. So required is a list of plugins that run before the data pack is loaded, and pipeline is ran right after it. So in the same way that's ordered in the slide, you require, you load your data pack and resource pack, and then you run the pipeline. JSON isn't actually ordered at all, so just because I've ordered it this way in my file doesn't mean it matters. It's mostly there for a sanity point of view, just because you don't want to put it in an order that doesn't make sense. Is there a standard way Beet plugins take in data from the end user to specify variables and such? Would that be under meta? Yes, that's a great question. Let's see if I can find. Okay, so this is meta. Meta is sort of a Python dictionary that's just listed in JSON. You have like a context.meta object on the context object in your Beet plugin, and that way you can define any sort of information you want. So all Bolt is it's just a plugin for Beet. So it actually just reads in this entry point and loads it whenever the plugin runs. But if you write your own plugin, or even if you write your own Bolt code, you can just put wherever you want in the meta, and it gets loaded. It's a very flexible piece of logic that Beet has. To be honest, the entire Beet config is a bit of smoke and mirrors. Every single thing in the Beet config is a plugin. And that sort of gets into some of the complex parts, which I need to hold myself back on before I blow everyone's mind. But yeah, the Beet config is just data driven and nothing is real. Is there any story behind the name Beet? I think Fizzy really loves naming projects after things that exist in the game. Actually, one of the predecessors to Beet was a program called Guardian, which is a different take on Bolt, and a lot of other Fizzy's projects are based off of Minecraft naming. I guess it's a bit of a trend. Why Beet? I'm pretty sure it was available on PyPy, and it's a 4-letter name, and he was like, "That's pretty awesome," so he got it. American Bagel, you should claim all of those and sell them. Actually, don't, but you could. It's good domain squatting.
Any more questions? We still got time here.
I might take a second to talk about the future of the Beet project. I didn't make any slides for this, but I realize it might be kind of relevant, especially with how Beet has proliferated within other communities. I think it's fairly important for Beet to have like a plan moving forward, especially because Fizzy isn't as available. So what's great about Beet is that there is a lot of uh, community members involved with maintaining it and adding new features. The goal really for the next, the next few updates is documentation for Beet. I think there's a lot of people that would really love to use something like Beet, especially integrating with their favorite tools. And the lack of documentation is very clearly holding it back, and it's probably one of the top priorities. There are also plans on simplifying the config format a little bit and the plugin format to make it a bit more composable. But yeah, it's definitely one of those stronghold projects that have really simplified management from an organization point of view. I see another question. What niche does Beet do best in the world of precompilers? I think really great question, because I think Beet stands a little bit different than most precompilers. It is fundamentally a build tool. And it's a toolkit. We really like to call it a development toolkit and not just a precompiler. Because it's not really compiling. It's mostly just giving you a format of maintaining your files. It's a project format and a tool that helps you manage that project. In the same way that you'd want to use Cargo in a Rust project, or Node maybe in a npm project, or like you might want to use Poetry in a Python project. In a Minecraft project, I think it's very helpful to use a tool like Beet. Even if you don't touch Python at all, there are commands in the Beet library that make it really simple for you to manage, your world. So for example, if you have a resource pack and you want to link it to your Minecraft save, you can just type Beet link with your Minecraft world, and Beet will automatically send every compiled data pack and resource pack to the correct place. It'll send the resource pack to your resource packs world or server, or to your resource pack folder, and it'll send the data pack to your world's data pack. And as nice as Beet Watch Reload will just reload your data pack every single time you make a change to it. It really is the comprehensive toolkit. And even if you're using a different precompiler, it can be useful on its own. And that's something we were talking about the precompiler talks yesterday. I digressed a little bit, but it's just a very handy project management tool versus just being a precompiler. I think that's the main thing where it stands out. Yes, Beet can be used along other compilers. I was actually talking at the pre-compiler fireside yesterday with the Zoglin and MC Build devs on potentially integrating um, a Zoglin Beet plugin or a MC Build Beet plugin. In the same way that Bolt is listed as a Beet plugin, um, why not have a Zoglin plugin? You can get the best of Beet and the best of Zoglin, and the choice is yours. So 100%. They aren't yet though. I think there's a Sandstone one, but that's about it. But I don't think the Sandstone one's maintained at all.
I think it's just calling like sand build, so I doubt it's broken.
Oh yeah, true. Yeah, as Huglet wrote, Bolt is extremely compatible, reverse compatible with normal data packing. So if you're just writing a data pack and you just want a for loop, you can just use it there, and it's like not that big of an issue. What is the use of Beet when not using Bolt? Without Bolt, you're just writing the same data packs but in another format. Um, that's actually a really good question. Beet has a set of plugins that just operate on that data pack. So rather than just adding new commands and operating on that, if you want something a little bit simple that doesn't even touch your commands, Beet just keeps it pretty simple. You just have a context object that goes through and um yeah, that's a good slide. You have a context object that can go through and read your file, and you can just produce whatever files you want. For example, in the Summit data pack, we had an issue with slash reload. Minecraft colon load was being ran immediately when the service started, but entities don't exist on the very first tick of the service starting. Entities exist like somewhat later. So every single data pack was detecting if an entity existing. And if it didn't exist, it just assumed it was dead, so it just resummon it. So for a good period of time, Summit was doubling every single entity in the world because a lot of people had this duplication code. Rather than writing a bolt to solve this, I wrote a beat that just took the entirety of Minecraft load and I put it in a delayed load function tag. And then I wrote a function that just checks if a player exists and then calls that function when finally a player exists, because that means entities are loaded. This is something I could have done in a bolt file, but it was really easy in a Python file because I already had everybody's data packs loaded into a single environment, so all I had to do was just take the final Minecraft load that was merged and put it in a different function tag. That's sort of where it's really powerful with Beet. It's not relevant um, to do everything in commands. Actually, yeah, honestly, half the plugins for Beet are not for MC function. One of the parts that I think are untapped for Beet is its ability to manage JSON files. Um, a lot of people are using Beet with just Bolt, but there's a big use case for making JSON file automation really simple. If you already are using Python scripts to generate some JSON files for like a world gen pack or just a bunch of advancements, you can write a Beet plugin to just generate that on the fly, create a Python dictionary, load it up, and you don't have to worry about reading and writing files. You don't have to worry about the file system. You don't have to worry about, you know, I guess files or like where to put things in data pack. Beat handles that part for you. It just gives you an API to generate files at the base of it. 100%. I think the potential for non-MC function packs to use something like B is really, really big. I think it's definitely untapped. Yeah, the structure to block model stuff is really nice. I've written a Beat plugin or a Bolt file that iterated through an NBT file, like a structure file, and generated a new structure file, or it generated a command based on that structure file. It's really handy for that. Yeah. One interesting part with Smith that we're working on is our Weld project, which is our pack merger. Weld is basically a wrapper on Beet. It adds a couple of plugins that add into it, but Weld is nothing more than a Beet plugin. That's the smoke and mirrors. Uh, it uses all of Beet's machinery to merge, and defines its own special merging rules. But the new feature we're gonna work on called Weld scripts, that's gonna allow you to write bolts in your data pack that only gets ran when you weld it together, which will allow you to like generate files for like all the biomes in the world. So I think one fun example is I've seen some packs add like a title when you enter a new biome. So there's like welcome you to the biome, or maybe like a title command that when you enter a new structure, you could write a weld script that you add to your data pack that iterates through all the different structures that exist in your world, generate a function file for each one, add a title to it, and then you can publish it on Smith. And then if somebody builds a bundle or merges your data pack with someone else's data pack that adds new structures, your code will just work. It'll generate all those function files when it's merged, and then somebody downloads that on the Smith website. It'll it'll just have extra code, and you could write that on the fly. It is what I call a superpower, and that's why I called this talk "Supercharging Datapacks with Beet." It works with resource packs as well, but data and resource packs isn't as fluent. But it really is supercharging your code, and I think that's what makes it really powerful. Um, I did not go into the depths of Weld. Honestly, a Weld panel would have been great for this, but maybe by the next summit, I'll have Weld scripts working properly, and I'll go into how Weld works because that might be a Summit 25 thing. What's the main thing when someone should look at using Beet with RPs? I'm guessing generating similar files is what's best. Um, oh, yeah. Generating resource packs and data packs are essentially the same thing. Your Beat plugin essentially you import the correct file, like a model file or like new item model file, and you just put it like instead of writing a JSON file, you just write a Python dictionary which has the exact same format. Um, but it just allows you to use Python variables, so you can use the very primitives of Python. Do a for loop of your model file and increment a number, and then insert it into that dictionary, load it into using context.generate, and you sort of have yourself a generated resource spec file. I think I have an example. Wait, is this an example? Yeah, right here. So in the same way that I wrote context.generate, you could import like a model file and do context.generate foo colon bar, and then you do model, and instead of sending a command, you would just send like a JSON snippet. But instead of defining it in a file, you have it in code, which allows you to do fireworks. And honestly, there's even a crazy way to do bolts with resource packs recently. Um, Fizzy recently released a plugin to write bolt exact just directly in your JSON file. But I don't know if I'll ever use that. I think we're getting towards the 2-hour mark, but are there any last questions I can answer? Did I miss anything in the live chat?
No, I've been watching them.
All right. Well, thank you everybody for tuning in into Beat. It's one of my favorite projects. It's honestly Beat is something that really got me into software engineering. Like I've learned so much about programming just with automating commands outside, like with precompilers, and a lot of my Python knowledge came from working within the Beat project, just everything that I've done with it. So I'm very passionate about Beat, and if you're ever interested in learning more about it, please join the Beat Discord. There's a whole community of people actually willing to answer every question. So even though we don't have docs, we have the combined knowledge of like a lot of people, at least 10, maybe. So please don't be shy and ask for help. And yeah, have a good rest of Summit. We have like 4 hours left. Isn't that crazy? We have 3 hours left. Oh my god.
Yep. Next up is the closing ceremony.